Nice to meet you all. My name is Adam Hoff-Nielsen, and I'm the director of the account management team. We're located in Copenhagen, where I lead the team, where we take care of customers in Europe and the rest of the world. And we've got an account management team in North America as well, taking care of our North American customers. Today, we're going to talk about cloud offering with x86. Maybe I'll let Rafael introduce yourself as well.
That's a quick intro. I'm a Chief System Services Officer. Basically, I'm in charge of the professional services team, and we are a team of 6 highly qualified engineers, some in the US, some in Europe. And one of the nice things about my team I'm very proud of is that we are slowly ramping up with the younger generation. So we're trying our very best to get the very extremely experienced masters like Dave and Thilo and Robert to train the younger ones with some of the really nice technology that VMS has. And the main advantage that we see, and you're going to see some of this on this presentation, is that by doing so, we can actually mix the new technology that the younger ones are very familiar with, and sometimes also the process they are familiar with some of the really cool older technology, more resilient that we see in VMS.
Right. So here's a brief overview of what we'll discuss today. I'll give a brief introduction as to why VSI has kind of entered the cloud sphere. And then I'm going to give you some business and technical reasons as to why you could move to the cloud. And then I'll hand back to Rafael, who's going to do a bit more of a deep dive into the technical aspects. Maybe it's more of a dive this time, because there are some other presentations by his team members that is a bit deeper of a dive. So he's going to do a light touch, and then he's going to hand back to me, and I'll explain a little bit of our different cloud offerings that we have, and also on how you can get onto the cloud with VSI. Then I'll hand back to Rafael, who will then explain some of the cases and also what are some of the next steps in our cloud journey. So you've all seen this, and we keep showing it because we're proud of our mission statement. But I think today's cloud discussion ties very well into the statement linking the past to the future. I think if you go back 40, 30, 20 years ago, who would have thought that you would put your core application on OpenVMS in the cloud? And this is, I think, a great achievement. But this transformation is not about disrupting your way of doing your business. It's actually about giving you a choice and giving you opportunities. So we're committed at VSI and giving you the freedom to adapt new technology at your pace, and also what fits with your business needs. And that's what we're focused on. So cloud, it's not a shift for the sake of change. It's actually feedback that we've had from our customers, talking to them over the last 5 to 3 years. It's a more reoccurring topic that's coming up with our customer discussions. So how are we working at VSI? We have these 3 pillars that we focus on: product development, new standards and technologies, and professional services. Again, with the aim of giving you the opportunities to adapt these new technologies and to give you the choice. And I think the cloud offering that we'll present to you today is definitely a very good combination of this mix, using x86 as an enabler to be able to introduce cloud, and also using the professional services team with the younger generation to actually adapt the new technology. So the Open VMS evolution, we all know that it was developed for proprietary hardware. And I think since VSI has taken over 10, 11 years ago, we're proud now that you, the customers, are able to run Open VMS on x86. We're proud that we launched it. We're not so proud of the delays, but I think we're very proud of the persistence and the fact that we stuck to it and we didn't throw in the towel. And we've also added open source products, the trainings, the services. And I think the cloud is only the next kind of natural step for us to on this OpenVMS journey. And that's why we've launched VSI Cloud, which is powered by Oracle, by OCI. And some of you might ask, why did we choose OCI? Why didn't we choose AWS, Azure? As a small company, we need to stay focused and we need to choose one. And I think because we focused on the basic needs, security, technical fit, manageability, pricing, the OCI Cloud was a very good technical fit for us and met those needs. And we were not focused on the brand. We wanted to have a good technical fit. So you've probably heard this as well, but why should you move to the cloud? And it might be harder for the OpenVMS generation to adapt such a new technology, but there are some very good benefits to this. I mean, first of all, the financial benefits of not having to have a very high investment in hardware, the depreciation that's involved, investing in DR machines if you need those as well. You can also simplify your operations with the cloud. You have a one-stop shop, you will have one contract, and it covers both your hardware needs and also your software needs, and potentially also your application needs. And we can do a very fast provision. So you don't need to worry about the firmware updates. You don't need to worry about patch updates. So very good for your operations as well. Strategically, it's also a very good opportunity for you. You could say that geopolitical reasons you might want to ship your service, or for other reasons you might want to ship your service. In this way, it's very easy to do this shift. Technical, you can enhance your security with cloud. Some of you might debate that, but I'll let Rafael take that debate. And it's a scalable environment, so it's very easy for you to turn up and down your needs. And we'll be able to provide you with the modern tools as time goes on. And in terms of human capital, that's also where you will be able to focus on where your IT skills are needed, where you want to focus your IT skills and where you want to outsource. So we can fill the gaps very easily. Say that one of your engineers is going on maternity or paternity leave or retiring, we can very quickly then adapt to that. But enough of me talking. Then I'll get you some of the technical slides. There you go.
All right. So I'll talk about from a very top level regarding the two topologies that we currently offer in the cloud. And one small caveat is that these slides were made about 1.5 to 2 weeks ago, before we actually had the solution also for native in the cloud. So all these slides, you see the diagrams, and they refer to nested virtualization, which means that we have two host OSs, so one host OS inside the other, and then that generates the guest. So right now, as we stand, as of about 10 days ago, we actually also have the solution of direct virtualization. So basically, it's just one host OS, which is not of our choice, it's basically Oracle's choice. We do happen to know it's most likely Red Hat, and then we run VMS direct on top of that. So just so you guys know that it's in reality, we can do like exactly as it's stated here, but we also have another option, which is removing one of the OSs and simplifying a little bit some of these diagrams, but I'll go with the original diagrams. Topology 1, we actually decided to divide into topology 1A and 1B, and it's the exact same topology. The only difference we would like to state here is that topology 1 can be made as a stepping stone to a different objective, or can be an objective on its own. So we start with your on-premise cluster. In this case here, we just decided that you have potentially 4 nodes, so we just decided to draw node 3, node 4. You have your local network, everything's fine. And the next step we have on your move to the cloud is to create one single node in OCI. And as you can see here, the node in OCI for no particular region, we decided that it would reside in Chicago. And just for the sake of completeness, Chicago has 2 or 3 different, completely separate, independent data centers within OCI. So when we say Chicago, it doesn't mean that it's a single data set. So you could actually have redundancy within the same geographical region in OCI. That machine is in a bare metal, which we do not have control of. It's basically Oracle's bare metal. And then that runs a level 0 host operating system, except most likely Red Hat, but we also do not have control of that. And then the original solution that we had, we would install Oracle Linux 9 on top of it, so level 1 host operating system. And that would have KVM, and then our level 2 system now is a gas operating system, and that is VMS. So basically, this is just to show you that for each instance we have in the cloud, we would be running one node of VMS as a gas operating system. And that is connected to the OCI VCN, so basically a network. After we have established that, so we can see very clear that there is absolutely no connection. So this is a fully isolated. The next step we actually take is to verify this node in isolation. What do we mean by this? We run disk purge, we run other performance tools to verify the transfer speeds, what sort of number of random I/O ops we can actually get, what is the speed of the network throughput, is it sustained, is it just a spike? So basically benchmarking the system to see if it actually meets your needs. And the idea here is that this is an iterative process, because the nice thing about the cloud, you can very easily slide the performance bars as you wish. And almost the totality of those performance bars can be slide at runtime. So you can just basically say, okay, I want one extra CPU core, I want 4 more gigabytes of RAM, or my hard disk size is perfect, but I would like maybe 3 times the performance. So things like that, we are going to iterate with you, your application team, basically check what are your requirements and make sure that the node in isolation meets those requirements. Once those are met, we have that blue tick box. Next step, for this topology one, I'll talk about the connection between the machines a little bit further on topology 2. But for topology 1, we would go with WireGuard tunnel. What is the reason to go with WireGuard? No specific reason. It could have been also IPsec, but we just decided to run with WireGuard because it was a little bit easier to set up in the host machines. So we set up the WireGuard tunnel. We connect basically then the Oracle network to your local network. And it's not yet a hybrid cluster because, of course, we then have to configure the hybrid cluster, but eventually we would configure the hybrid cluster, and now you do have one node in the cloud with your remaining existing nodes on premise. And this process we can rinse and repeat as many times as needed. And just for the sake of clarity, we decided now to choose a different region, in this case, Frankfurt 1. And same process, so basically fine-tuning the machine. Of course, this time the fine-tuning, the iteration will be much faster. We have much shorter turnaround time because we already know more or less the specifics and the criteria that we need from the last time we actually ran this iteration. And same steps, connect to WireGuard. Now we have not only a hybrid cluster, but a geographically dispersed cluster, both cloud and on-premise. Right, so what is the difference between topology 1A and 1B? 1A, this could be an end on itself. So what do we mean by this? Maybe your objective is exactly to distribute the risk geographically, maybe because of geopolitical reasons, could be because of distancing that you need between your servers. It could be that you just want to try the cloud. So this could be an end on its own. But what we also see this is as a process potentially to a different objective, which now we call 1B, which we start with the exact same, but we slowly disable your local nodes. This is also what we call the process of a lean migration to the cloud, because your cluster is one by one node added in the cloud, one by one node removed from your on-premise. So if your objective is to move your cluster fully to the cloud, we do not recommend that you just do a full shutdown and then spin up your 3 nodes in the cloud. No, instead, let's try to do it lean. Let's do one node at a time so you do not have actually any downtime. And we have more time also to iron out all the bugs. We have also more time to better set the performance of the machine. So we would disable one node, verify that indeed the cluster still runs after that one node is disabled, and then rinse and repeat until you actually have a solution that is now fully cloud only. And this is an option for topology 1B that you can just leave it running WireGuard. There's absolutely no problem in it. But the WireGuard is actually run on your host, which actually means that your communication will be encrypted by your host, which means it is using the CPU you are paying for. So it is taking some power away from your host for all the encryption of the network. If your network traffic is not very dense, it's absolutely no problem. But let's say you have an extremely intensive network application, this could potentially be a bottleneck. And for those cases, we suggest a small change in the topology, which is instead of using WireGuard, we use something called Dynamic Routing Gateway, which is an Oracle technology. They basically abbreviate to DRG. And the advantage of this DRG is that it's no longer residing in your host, it's actually residing in Oracle itself. So they have exclusive machines that take care of the encryption of your communication. In our case, it'd be basically cluster communication or pod communication. And that encryption happens because it happens in specialized machines and no longer in your host, it's much more efficient. And these DRG, they are also encrypted 128 or 256 bit encryption key. So it's something that you can also ask Oracle to fine tune. So as an alternative to the WireGuard, you would then connect the DRGs to your local nodes and connect the two regions via a remote peering connection between the two DRGs. And in that case, you test, verify everything's fine, and you would be able to remove the WireGuard. Once again, that's an optional step, just in case the performance requires such a step. So that was topology 1A and 1B. What are the main characteristics of it? First is that 1A enables a lean transition, which then becomes 1B. What we mean by this, you add one node to your cluster in the cloud, verify, set everything's fine, please repeat, and remove the node from your premise and go like this. Second, it enables us to have a much better management of risk. When we're doing one node at a time, it's very easy to control Z any problems you might have. So if you have added a node in the cloud, remove the one in your premise, and after a while we realize, oh, there is something a little bit weird here. Let's get this back up and running. So we can much easier reboot again your node on premise, go back to the solution that was before. So we have a very, very tight control on the risk involved on the migration to the cloud. Much different than, for instance, a solution where we just shut down everything and then we just start again in the cloud. So it's basically what we call make before break, because we're actually creating a new node before breaking the previously existing node. It's an iterative process. Like I said, all the lessons we have learned on the first node that we actually put in the cloud help us to reduce the time it takes to put the second and subsequent nodes in the cloud. So compared to, for instance, running all 3 or all 4 brand new nodes at once, that is generally a process that takes longer compared to this, because this means that the learnings are intrinsically inbuilt into the process as we build more nodes. And final is that very clearly topology 1A can be just an end on its own mean. So you can run a hybrid cluster, but it can also be a stepping stone to the end where you want to have only cloud-only cluster. Right. So topology 2. What is the difference here? The difference with topology 2 is what if we actually have a clean slate, in the sense that there is potentially no problem with downtime, or you would like to just start a brand new system for a brand new application, for a brand new development or deployment that you have in mind. So in that case, we can make use of a few different steps, not necessarily to reduce risk or anything like that. It's just to make the process a little bit faster or a little bit more streamlined. And this example here, we decided to do a little bit different, just not because it is needed, it's just to show you that there are many different ways you can actually come up with a topology. To the right, we still have Chicago, but in this case, we actually decided to represent 2 hosts, and each host has 1 guest inside of it. And on the left, we have Frankfurt, and same thing, 2 hosts, 1 guest inside each host. And because we have a clean slate, we decided to already start with the dynamic routing gateway. And it's interesting to point here that the dynamic routing gateway is not per host, it's not per guest, it's actually per subnet, or local subnet. So as you can see, there is 1 dynamic routing gateway for Frankfurt and 1 dynamic routing gateway for Chicago. In this particular case, you would have a 4-node cluster, which most of you are actually looking and like, that is maybe not necessarily a very good idea. And because we cannot do shared quantum disk between the regions, what we actually use them as a solution to make odd number of voting is to have a quorum node. In this case, we decided to go with a quorum node in London, just because it's a third region, so it adds redundancy. But also for this example, it's interesting that London is geographically in between the other regions. Not exactly in the middle, but as close as you could get. Maybe in Ireland would be more in the middle, but you guys get the idea. And this cluster then is what we nicely named the triangle cluster, just because it's a 5-node and it does form a triangle. The guys from professional service, they will talk all the details about this. So all the sort of errors we try to simulate. So all sort of breakage, the DRGs, connections going down, latency. So a lot of different things that we have poked the cluster with and see how it actually behaved and what were the results. And well, just to spoiler alert, everything went fine in the very end. There was one condition that we were actually a little bit surprised at the way the cluster behaved. But then looking at the source code of the way the voting system actually is supposed to take place, we realized, okay, this is actually as it is supposed to happen. The way that the cluster managed once some nodes were partially removed from the cluster. But yeah, I don't want to spoil too much. There'll be the presentations today at 3:30. So 3:30, the guys will talk all the details, not only about topology 2, but also topology 1. Right, so what are the advantages of the characteristics of the cloud only? So regardless if you came to cloud only via solution 1A, 1B, or solution 2, what are the main advantages? Now, the geographical location is your own choice. If you have to move your servers, you no longer have to move them physically. And I can say from personal experience being head of professional service, we did have cases where customers came to us with the exclusively intention of like, can you help us to actually transport our servers from one given data center to the other because of regulation compliance, because of geopolitics, things like that. Now, if you have the cluster in the cloud, you can do that with the push of a button. And most of the times, you can even do that with very minimal downtime. And when I say very minimal downtime, we're actually talking about millisecond time range of downtime for this cluster. This is not a technology that we invented. This is something that is intrinsic to Oracle. So Oracle Cloud Infrastructure, they have these special lanes, internet lanes, made exclusively for moving of their cluster between their regions. And they are very good at that. So that's why they are able to do almost in a streamlined, live manner, just this milliseconds of downtime. Next major thing is if you have a cloud-only hardware tuning as you go, it's very, very easy. First of all, you don't have to send a person to your data center to now shut down a given server, snap in a few memory modules, or swap your hard disk, or swap your CPU, or perhaps even like clean up your fans because they have built some dust. No, there is none of that because it is in the cloud, and all the performance tuning is basically drag buttons, change numbers of fields. It's very, very simple, and most of them are actually activated on the go, so real time, almost hot swappable sort of technology. Next, creating a node is very easy and quickly. We are now able to create a node from scratch with our scripting system, so basically nothing to a VMS prompt in about 15 minutes. So that's how fast you can actually create a node all from scratch, and that is considering a fresh installation. There are some technologies the guys will discuss today, which is transplanting a pre-installed QCOW, and that number, that basically time can be reduced to about 2 to 3 minutes. So it's very, very good. And final is that the fact that you no longer have the need of a person to be able to go in person to a data center means that you can actually distribute your team worldwide coverage a lot easier. Because now, if you want to have 24/7 coverage, they're no longer bound to their travel times to the data center. They're actually now bound to their working out worksheet schedule. So it makes it a lot easier to better manage your team, potentially even have a more reduced team and more specialized team on the tasks that they really have to do, which no longer are actually related to maintaining hardware. All right, so this sounds like really good news, really good technologies. How does it generally go about? Let's say one of you want to actually, I want to try this. What is the next step? Okay, very simple, generic answer. Contact your sales person. But what would happen? And so we decided to give you a more or less idea or what are the main questions, what are the main things we're actually looking at when we go and we have a very open and frank talk to you to see what is your need, what are your requirements, what are you expecting from the solution. So I'll start from the bottom. First question, have you started the port to x86? Why do we ask that? If I haven't started the port cloud is not for me. No, it has nothing to do like this. Because if you have not yet started the port, but you actually let us know, we can configure the cloud in such a way that will be more beneficial to your developers rather than actually your system maintainers. So the idea is that we want to have a good overview of which stage of the process of the migration to x86 you're actually in, so that we can also plan our cloud deployment exactly to fit your needs to that migration. Next, do you have any very, very specific hardware or other type of requirement given your application? So a good example, let's say you are a steel mill, or let's say you are an oil producer, or let's say you are some form of company that relies and have a direct connection to a production line. So you must have some requirements in terms of latency, right? You must have requirements in terms of quality of service, particularly on the network side of things. So it's very important for us that we discuss these very openly. Another good example is, I have been running with fiber channel for the last 10 years, and I was really considering now moving from the 16-bit to the 32-bit fiber channel. Right, in the cloud, we do not have exactly the fiber channel, but we have other technologies that may fit your needs, particularly when it comes to the I/O, random I/O, or also the throughput that you get from your hard disk. So it's very important for us to discuss what are your very specific requirements, particularly to your field of application, where the cluster will be responsible. Yeah, example is process control PLC. That's one of the best examples for latency. What are your geographical restrictions, right? Is it geographical restrictions because of regulations? Maybe you do have geographical restrictions. Maybe you're in the banking sector, for instance, where your data has to reside in a certain country, and there is no option around. We can set up for that. Maybe you actually have restrictions that parts of your cluster have to reside in a certain area, whereas other nodes have to reside in other areas. We can also set for that. So it's very easy for us to move the nodes around, but it's also a good idea for us to know from the get-go, so we can plan for this and perhaps minimize some of the potential wasted time in the later stage moves. Next, I want to talk a little bit about the hypervisor. It's not a cloud technology. In essence, it doesn't have much to do with the cloud. But if you are taking the step to move to the cloud, it's generally a good idea to also use that opportunity to change the hypervisor if that is your wish. What do I mean by this? Let's say you have been using a certain hypervisor which shall remain unnamed, which was bought by a very big company who decided to hike up the cost and the fees for that, right? And you're not very happy about that. And what do I do with this? Well, should I talk to my IT team to potentially move to KVM? Should we do something? Well, if you're moving to the cloud, it's actually a very good idea to do at the exact same step. And once again, by using topology 1A or 1B, where we do a very lean process, we change one of your nodes from that particular vendor to KVM, rinse and repeat, clean and see performance, check all these type of things and move on from there. So do let us know if you are currently with this sort of question in your head, should I keep the certain hypervisor running or should I move to another one? And we can put this as part of your cloud migration project. And last but not least, what are your requirements in terms of quality of service, uptime, resilience of your server, etc.? Because intrinsically, when we start the host in OCI, by default, we always start with the equivalent of vMotion, right? So OCI has its own terminology, but for most of you, it's what we understand as vMotion. So basically the idea that your machine is not bound to one specific server, but it can sort of like float and bounce around. So you do not have downtime on your system if the original machine that you started with actually goes in maintenance. That is the default choice. If, on the other hand, you would prefer, for whatever reason, that your image is always bound to a very specific machine, that is also possible. And in that case, if there is a maintenance period coming along, we would inform, we would let you know, and then you would be made aware that it would be a downtime because you decided for a machine bound. But generally speaking, we run in the cloud with the equivalent of vMotion for KVM for us.
Absolut.
Thanks, Rafael.
Thanks, Rafael. I think it's worthwhile also just noting here that when we presented this store, you're going to stay humble here, but they were pretty impressed with what the team has achieved. And I think it's worth noting here that we've managed to actually impress what they've done here, and that's exactly bringing in young people here who are eager to learn. But what kind of offerings can we offer you here? It's very much in how much you want to be involved as a customer and how much you want us to take over. And this is going to give you a spectrum. So the first one is where we basically boot up the host for you, and you keep the super user access. That's kind of what we call the basic control, and we manage all the DOCI settings. Next, we install some monitoring tools, so we give you alerts either by SMS or email if there are any issues. And the more we move over to the right, the more we take over our involvement. We also then, this is more 24/7 kind of monitoring, where we also monitor you 24/7. And then the full management, where we basically oversee all your performance, all your uptime, security, and we also deliver you monthly reports. So we basically make sure that your application, you're still responsible for your own application, but we make sure that everything around it works 24/7. And then the last step, and I think it was also mentioned by one gentleman yesterday, is software as a service. Well, here we're getting very close to that, because that's application management, where we take full control of the application as well. So this depends very much on your needs as a business. You have people retiring. Do you need more help with the application? And you can then kind of move within this spectrum of our offers.
Well,
Go ahead.
We just want to emphasize here that this is a spectrum, and also the position that you would like to be in the spectrum is very time dependent. So it could be very well the case that at the beginning you want us to do a little bit more for you, but as you become more knowledgeable and acquainted with the cloud services, you want potentially to take more responsibility. Or the other case, as Adam was mentioned, that maybe your team is actually reducing, therefore you'd like to release some responsibilities. And a very good example, we're going to talk about one of our cases. So Duncan is sitting here, and he has been one of our best customers, particularly with the cloud, because he has been very patient as we went through this journey. So a quick note is when we started with all the default settings, and we tried to run with that. And the first machine we actually delivered to Duncan had a throughput of hard disk of 3 megabytes per second. Right? So it was a little bit painful. So we are very grateful that Duncan was so patient with us. And that was a good example of the use case, because at the very beginning we started with the knowledge, let's just deliver to them a VMS system, and TDL, the use case, would have then access to the VMS also. That was the original idea. So we would be probably between the first and the second blocks there. So there was customer involvement, but exclusive on the VMS side of things. And as the project progressed, and as we saw, like, oh, not only they want to learn more, but we also would like to have the opportunity to have an example when we release more. We slowly shifted the position on the spectrum where we resided in terms of the responsibilities, to the extent that Duncan in the end had access also to the level 1 operating system, so basically the host, and he could go and configure some of the settings like KVM, things like that. So just one extra example that where you are in the spectrum can very easily change from day to night. And once again, our cloud offering is not to restrict your options. It's quite the opposite. We are here to give you more options. And as part of that, we are very committed to not having a informed position, but actually a movable position that fit your needs at that given time.
Thanks, Rafael. So how would you begin this journey with us? Basically, reach out to us. That might sound very basic, but as Rafael is working very, very young and eager engineers, they're actually very interested in hearing to what you're playing with. So please don't hesitate to drop us a mail or pick up the phone and set up a meeting with us, because it also shows what your needs and requirements are. And we actually need to because we're all learning here. So we want to get some feedback from you. Next, that most of you already know, we'll do a discovery service, and we'll run the BSI support script. We'll set up a technical meeting with you, and we'll do a brief sanity check whether or not this is something we should forward with. We then do a pre-study, and at this point we'll of course sign an NDA with you, and we'll need access to your systems to be able to dig a bit deeper into your application and to see if the Rafael and team is able to set something up. And then we'll go along with the proof of concept, and of course to work to show that this application can run in the cloud in practice, and this would probably be in the typography 1A or 1B, where you still have some on-prem nodes running. And then we go on to the deploy, where you as the customers will probably be more involved, because there will be about testing and building the environment. And then we go on to what we call the run phase, which is the production running in the cloud and the go live decision when you feel comfortable with that. So maybe you want to, and hopefully some happy customers, and there you go.
So we decided to present you 4 different cases, and the criteria we used here to select the cases was how different they actually were. Just for the sake of context, we have currently about 50 hosts in OCI for all sorts of different projects. And I believe if we sum all the SVM that we are running with over VMS, it's probably closer to the 100 to 200 range. So we have a lot of different cases that we have already tried in OCI, but we decided to choose 4 here. So first and foremost, the customer CDL with Duncan. We have to say nothing but thank you for being with us in this journey. We learned a lot. And their application is actually a single node. So that was particularly also interesting for us, because it was an easy stepping stone to what we managed to build at them. We started this journey, I believe it was in August last year, and we had the single node ready and set by November, December, after we had all of those iterative settings and fine-tuning the performance. The other interesting aspect about that one node is that there are many multiple external network connections to data brokers and data providers. So there was a fair amount of configuring for firewall and things like that. So it was not only about the instance, it was also figuring out how we set permissions to the Oracle network and related matters. The second example is what we call the nicely called herder, which is a server with massive number of VMS instance running in the same host. In our case, we set up the herder to be able to run up to 60 VMS instances. It's not something we recommend, so our recommendation is to have 1 guest per host, just for the sake of redundancy and reducing any sort of potential issues if your host goes down. But we decided to showcase this because for all of you who were in the presentation yesterday, when we talked about the herder, the objective here was to be able to install and launch and configure almost as many VMS images concurrently as we could. So this is an interesting use case to show that the cloud is also capable of running a single host with many guests. And for most people, this is not a production scenario, but it would be a interesting development scenario. So you can actually get a single machine and give 30, 60 of your developers each their own VMS guest, and that is perfectly fine to be running. The examples 3 and 4, I will actually, I have actually mentioned a little bit by doing the topology 1A and also the topology 2, but I will not give too many details because the guys from professional services, they will cover all the small intricacies of these 2 examples today at 3:30. So they will be the one in charge of telling you how you actually start to form the triangle. Should you actually connect first the 2 nodes on each side of the triangle and then mask the longer, or should you do the other way around? How does it actually behave when you shut down the DRG? How does it behave when you try to simulate network instability? So they will be given a lot of details of this, but we decided to leave these 2 examples just because they're very meaningful, since they are the basis for most of your migration to the cloud. Okay, so final slide. We want to make very clear that we are here actually to hear you. And to the same extent, we would like to pitch some ideas, and we'd like to hear, does that sound like something you really want? Does it sound something like you need? Would you potentially ask for different things? So we really want to have this interaction with you. Like Adam says, this is a learning journey for us as well. So here are some of the goals we actually foresee for the future, and I'll talk a little bit briefly. And once again, just tell me like, oh, this makes absolutely no sense. Why are you doing it away? Or, oh, this is a good idea. Or have you considered an alternative, right? So first goal that we have is actually come up with templates, or what in x86 sometimes it's called appliance. So basically the idea that you would have the ability of starting directly to the terminal with very few configuration, very few clicks. In a perfect world scenario, you would have a certain field where you select very small configuration of the machine, maybe CPU, RAM, hard disk, click go. Within 1 or 2 minutes, you have your VMS prompt. So this type of solution is something we are really looking into. And as an extension to it, we are also considering the idea of pay as you go. So you would no longer have to contact your sales representative. You would no longer have to download image, download kits, download licenses, apply, install. No, we're looking also at the concept of, I would like a VMS machine, fully legal, fully licensed for the next 4 hours. And once I'm done, once my developers have deployed their software, we have run our tests and we have decided that everything's fine, I want the machine to be just erased. So this is also something that we are looking into, software as a service, but also from a perspective of a temporary deployment. So we heard particularly 2 customers in this bootcamp talking about this, and that's such a feature. So if you have the need for it, please do let us know, because it's something we're looking into. Third is the automatic custom installation. So perhaps what you need is not just a prompt with the default install, but you would actually like a prompt with the default install plus web UI plus SSH plus, I don't know, COBOL compiler. So trying to make your, let's say, temporary development machine as close as possible to what your developers would expect as a starting point. And one of the hidden advantages of actually having such technology is that all your developers, if they do select the exact same options, they would start with the exact same configuration machine. So you do have some sort of intrinsic configuration management that will prevent the regular proposition of developers, which is like, no, the software is fine because it works on my machine. Right, but we are no longer talking about your machine. We're talking about a machine that everyone has. Everyone starts with the exact same copy. So that's something else we are considering developing. The fourth point was actually a next technical goal, but like I said, about 10 days ago, we managed to do the cloud native. For the ones of you who want to try, this is not a technical presentation, but I'll just give a few hints. The way we did with cloud native, there are 2 ways. One, you can transplant your QCOW. So the idea is that you generate your QCOW on your KVM, hopefully with a KVM setting very close to Oracle's own KVM setting, so you can just copy and paste the QCOW and boot on OCI. That is option 1. Option 2, for all the customers that actually want to go through the installation, all the many steps to be 100% sure what went into that QCOW. The way to do that is via NetBoot. So you can contact us if you'd like more information. The guys will also talk about this, but basically, surprisingly enough, all you need is in the ISO. So you do have to extract and load from the ISO, send to OCI, run the netboot, and then load the ISO again via HTTP server. But all of that is already included in the ISO 923. That's the version we use for the netboot. And yeah, in about 10-15 minutes, you can actually get a fully running OCI machine, which is non-nested. It's just direct virtualized. And number 5, what we have is IPsec. And the reason why we actually decided to add IPsec, even though we already have the WireGuard script installation technology, is because Oracle has the DRG, which is its own technology for encryption of networks, but they also support IPsec as external to host part of VPN, and they currently do not support WireGuard. So the advantage of running IPsec would be that all the encryption load would no longer reside on your computer as CPU, but it would also be on an external computer of Oracle. So that's something we're considering as an alternative to WireGuard as means to connect to your local network for your locally residing nodes. And number 6, like I said, please do reach out. We're here to hear you. We are here to actually exchange a few ideas, exchange some of the problems we have. We did have also some customers approaching us, oh, I tried this, I tried that, and why did it not work in OCI when I tried it? We had a webinar in December, and that was actually particularly interesting because we got a lot of feedback from customers trying out some of the steps that we had mentioned, and for them they found different results. And this is very good for us because then we determine the particular cases or particular settings that may interfere with your installation. So do reach to us. We want to really hear and discuss and think all these ideas back and forth.
I think that's it. Now it's questions.
Just a quick one. I fully understand that you're working with Oracle, but I moved quite a few customers to the cloud. And the important when you move to the cloud is that you have the freedom to actually move to another cloud. Have you done any evaluation of alternative in case the price suddenly explode at your current cloud provider?
We have not done any evaluations of different clouds, but we did have one separate team with our cloud that they tried AWS.
Yes.
And they actually stopped on the fact that they could not do nested virtualization. So AWS was supporting only direct virtualization. And as you know, we have quite strict requirements on the chipset. So for instance, Q35, vertical net, vertical SCSI, things like that. And I believe that even when they decided to try a non-nested, they could not because of the difference in chipset. So that was one example of this. And Azure, we did have customers coming back to us that they were able to install nested virtualized in Azure, but we have not tried it ourselves.
It is important when you are moving to the cloud that you have the option. Not that you want to leave, but that just that you have the option.
So we're having a little ambassadors discussion at the moment about single member nodes, single member shadow sets. So I know you sort of touched both standalone systems and of course clusters, but particularly I think I can see that a single node cluster and single member shadow sets would actually be enablers to allow people to move from a single system into this, because you create shadow sets which are single member, and then as you're doing the transition you can actually make it multi-member and then go back to single member. So it's almost selling the idea that maybe having single member nodes, single member clusters and single member is possibly something you should be looking at on x86 to enable this to work much more smoothly. As an engineer over many years with so many different technologies, just having a device called DSA and being able to switch on that SES connection would make this journey so much easier.
Yes,
my opinion.
It's very true. The architecture 1A and 1B, we gave the example of multiple nodes on premise being slowly moved one by one to the cloud. But there is nothing that prevents a single node on premise to be converted into a cluster of single node. Then we add one extra node in the cloud, and then we move that single node on premise to the cloud. So everything that we talk about, multi-node cluster, could actually be applicable.
It's in terms of licensing, because obviously if you switch on shadowing and clustering, you need a license to do it. So it's that argument: should that license be chargeable, free? Should it be low cost? In order to permit this journey.
I know the answer, but I'll let the official person.
Something we'll take with our afterwards, I think. But,
No.
My reflection of clustering over IP was with the latency that affected the latency limits between sites. And you were talking about having virtual hosts in different geographic regions. How do you cope with those latency? There's a later problem.
The guys will talk about it, but I know some of the numbers in my head. So from boot to cluster formation, that triangle one, and the triangle is a harder one because it's 3 regions. I believe it was about 4 or 5 seconds. So that was the time to. And once one of the nodes drop out, the time for the rearrangement was sub-second. Those are the numbers I remember in my head, but the guys have a lot more of the details and the information. And when they tried the node dropout, they tried through completely different means. They tried through whole shutdown without warning, so basically like just literally unplugging. So 5 systems not working. They tried through DRG breakage. They tried through injecting random packets. They tried through cut of the remote peer connection. They tried through many different ways, and those were the numbers that they basically always saw.
What about the storage and latency between nodes that you're in the distributed cluster?
So when it comes to storage, maybe I'll do a little bit of a recap here. Oracle differentiates between boot storage and block devices. And officially, once you have something stored on a block device, which is not a boot device, you cannot boot from it. Unofficially, we have seen and we have been able to do once that if you go and you edit the configuration of Oracle's own iPixie, you can actually request a boot from a known boot device. It's not recommended because they try to give higher performance for the boot device instead of the block device. By the way, regarding the question of different cloud providers, one of the nice features we have found out recently with Oracle is exactly this, that you can provide your own iPixie script that Oracle runs directly at boot. So you can actually bypass all their configuration, even at the boot time. What is the second part of the question?
Let's just, latency, so you sure three node cluster in the starting node.
Right.
The on-prem, and so the customer has the storage on-prem. Now you're moving to the cloud, so now you have, the storage has to be located in, one of those places or both the places in the shadow, then you end up with latency between. How's that?
Right. So the latency performance figures we have seen, we have done a lot of the network testing, particularly with the Frankfurt server. And the turnaround times that we have seen, they were sub-millisecond. They were about 200 to 300 microseconds. Those are the turnaround times. So there's not too much latency. We have not tried directly the latency specific to storage. One other thing to consider is that in OCI, you can have replication and automatic backup of your block and boot devices. And this is done seamless without any intervention, super quick if it is within the same region. But they also provide long-term backup across regions as well. So that is another thing that is possible. But specifically in terms of latency, those were the figures we saw with the Frankfurt servers.
Does the connection between on-prem and cloud require Oracle Fast Connect to get those latency speeds or no?
It's not necessary. So the smallest host we've had, I believe the network was 3 or 5 gigabit per second, and we actually got very, very close to the performance promise. We've been like 20% sort of close. Technically, we have seen more latency and more, let's say, degradation of the network, not because of the network, but rather because of the encryption. Right? Because if you're running cluster, everyone remember, if you're running cluster, please encrypt. I think it's the second, third time we already say this here. But yeah, so the WireGuard or IPsec, whatever you're running, that tends to add more latency than the network itself. In terms of the performance, I think it's also interesting to notice. So the network was within 20%. But the performance of the hard disk, when we were tuning, that's something that we realized with Duncan, it was nearly spot on. And when I say nearly spot on, it's about like 1 or 2% from the promised speeds. So when you slide the bar in Oracle that, instead of 3 megabytes per second, I want 300, you're probably going to get like 290 at least. It's very, very spot on.
We'll have to take the rest of the questions offline.
Yeah. Look up to our
Session. Yes, I tasked was this present this and so we hours kind of confident so start that internal it's always it's possibly but it's quite
We have heard about the possibility, but when we started the interaction with websites, it was one of the things they were telling this. But we have never done because you require certain volume for them to actually do. So there is a minimum number of bare metal nodes that they will can be able to install. And we do not have that volume. That's why we like.